This is the second video dealing with looking at the technique of change of variable for evaluating limits. So I'm going to look at another problem. So we have limit as x approaches 0 of x plus a to the power of 1 over 3 minus 2 over x. So when evaluating limits, the first thing you should do is you should check if you can use direct substitution. So I'm going to try that here. I'm going to substitute 0 in. So if I put 0 into x here, I'm going to get a to the power of 1 over 3. So that's just the cube root of 8, which is going to give me 2. So, and then I have minus 2 here, so 2 minus 2 over, so putting 0 in for x here, what I get is I get 0 over 0. So in calculus, this is known as the indeterminate form. So whenever you get 0 over 0, it basically tells you that you can't use direct substitution in order to evaluate the limit, and you're going to have to use a different technique. And so, as in the previous video, I'm going to use the change of variable technique. And so I'm going to start by letting u equal x plus 8 to the power of 1 over 3. And so in that case, just to try to isolate for the x, I'm going to have u cubed, so I'm going to cube u, and I'm also going to cube x plus 8 to the power of 1 over 3 to get rid of the cube root. So I'm going to get x plus 8. Now what I can also do, and what you're going to have to do anyway in order to know what x is equal to in terms of u, you're going to have to isolate for x. So x is equal to u cubed minus 8. So I'm just moving the 8 over to the other side, isolating for x. Okay, so now the next part, because what I'm trying to do is I'm trying to write this expression in terms of u, is now I have to change this part. As x approaches 0, I need to determine what u approaches. So as x approaches 0, u is going to approach. So to determine that, we have to we can either look at this part, at this equation, or we can look at this equation. So if I make x 0 here, u would have to equal 2, right? So 2 to the power of 3 is going to give me 8, and 8 minus 8 is going to give me 0, right? So that tells me that u is going to approach 2 as x approaches 0. And so now I'm ready to be able to write an expression in terms of u. So I'm going to have limit as u approaches 2, and now I'm going to replace the x plus 8 to the power of 1 over 3 with u. So I'm going to have u minus 2 on top divided by, and the x I'm going to replace with u cubed minus 8. So u cubed minus 8. And so on the bottom I have a difference of cubes. So I'm going to rewrite that. So limit as u approaches 2, u minus 2 over, so what the way I'm going to leave this as u cubed, but I'm going to write the 8 as 2 to the power of 3, just to make it obvious that this is a difference of cubes. And so in the previous video, I showed you the formula for factoring a difference of cubes. I'm just going to write it here as well, just as a reminder. So a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Now in this situation, a is going to equal u, and b is going to be 2. So now factoring this, so limit as u approaches 2, so u minus 2 on top. So this is going to become u minus 2 times u to the power of 2 plus, so AB, so A is u, so B is 2, so 2u, and then plus B squared, so B is 2, so 4. And what I can do now is I can cancel out the common bracket, so the common factor, and I'm going to be left with, so limit as u approaches 2 of 1 over u squared plus 2u plus 4. And now all I have to do is I have to put substitute the value of 2 in, and that's going to give me 1 over, so 2 to the power of 2 is 4, plus 2 times 2 is 4, plus 4, so 4 plus 4 plus 4, that's going to be 1 over 12. Okay, so the goal in these problems is always, almost usually you're going to get a difference of cubes, and the goal is usually to factor the difference of cubes and then to cancel out a common factor. And after you've canceled out a common factor, you would then be able to substitute whatever the value here is, in this case is 2, into the expression to determine what the limit is equal to. Okay, I hope these videos were helpful in clarifying this concept. So thank you for watching, and check out some of my other videos, and subscribe if you enjoy watching these videos. Thank you.